Hello everyone. Today's we are gonna learn about trees. What is trees? How to implement trees. So, trees. What is trees? Trees are basically data structure. It is like array, linked list, and hash tables, etc. So, what is trees? Trees are basically hierarchical in nature. So, tree is gonna look like it is like every node every node having a two node left and right. It is 23. Suppose it is 23, it is 20, having a having a data which is called as data, having node having a data and two pointers to its left, two pointers to its left and right. So this is the description of a node. So let's see. Then every node having a two child, 9, 10. It will be a same or it will be a different, so it doesn't matter. So what is the example of files in real life, trees in real life? So as we can see, our file storage in computer system, in computers, like when we open file manager, so first of all we comes to our home page, home directory. So in home directory there are multiple directories like downloads, downloads, documents, pictures, etc. And in download there are more directories. In document there are more directories. Suppose we download a zip file, so again it is having more files in it. So this is how tree looks like in real life. Another example we can say relations. So our grandparent is related to our father father and mother. Then here comes we, children. So this is how gonna tree look like in real life. So what are the basic terms we need to understand in tree? First of all, we need to understand what is parent node. What is parent node in trees? So let's see some terminologies in trees. Let me rewrite it. Terminologies in trees. So what are, suppose first first of all we make a tree. It is a node X. It's connected to its left child with the Y. It's connected to Z, and Y is having A child and B child, while Z is having three child, C, D, E. Simple. And D is having two more child, F and G. F and G. So let's see. What is root? Root is basically our head of the tree. where trees trees started. So this is our root node. So what is subtree? So basically, if what we can say, we have to find subtree of a y. Subtree of y. So subtree of y is this part. Subtree of y. This is gonna represent subtree of y. Subtree of y. Mm, what is leaf node? It is known as leaf node. What is leaf node? Leaf node is that node which have no children, which does not have children, which does not have children. So what is children? Children are root node having their nodes left and right, which are usually known as children's. This is children, this is children. Children's of y is, this is also children. This is children of x, children of x. This is children, children of y. This is also children of y. Child of y. Simple. So there are two more terms. First of all, descendant. So what is descendant? Descendant is nothing but descendants. Descendant is nothing but, suppose we have to find descendants of y. So descendants of y is basically the children's. So children's of y is a and b. A and b. And another term is first descendant, then ancestor. Ancestors. What is ancestors? Ancestors are nothing but, suppose we have to find ancestors of g. Let's see. So if so, nothing but going in straight line, parent to parent. So if we have to find ancestor of g, so what is parent of g? It is d. So we have an ancestor d. Now what is parent of d? Z. Z is parent of d. Who is parent of z? Z is parent of x. So z is parent of x. So these are the ancestors of g. Simple. Now we see how to implement. There are few more terms. Let's talk about what is degree. What is degree? Degree is basically means it connecting node. So what connecting node? Number of node connected to that particular node. So if we have to find degree of y, degree of y, so degree of y is 1 2 3. We have also counted its parent node, the number of connecting node. This is 1, this is 2, this is 3. There are 3 connecting nodes with y. So degree of y is 3. We have to find degree of z. So degree of z. So how many nodes are connected to z? 1 node, 2 node, 3 node, 4 node. There are 4 nodes connected to z. So the degree of z is 4. Simple. Now we see how to implement trees in C. So let's start. So first of all, we have to include files in C, header files. What are the header files? So the header files is hash include studio.h. Another is for input output, studio.h is used, .h. Now we have to define structure. What is structure of tree? Basically, first of all, we have to make a binary tree. So we are taking in binary tree, basically we have every parent having two children, not more than two children we have in binary tree. So type def struct tree node, and in tree node we have a variable data name and every node having a two children. So struct tree node left, we gonna left child, we gonna name is left child, struct tree node right. So this is our structure gonna look like. Now let's come out tree node. Now let's write the main part. So in tree, first of all, we have to declare our initial node. So how can we declare or create our initial node? So it is a return type of tree node, create node, taking input as integer data. In integer data, first of all, we have to make a temporary node called as result node tree. Result is equal to initialize dynamic memory size of we have to give size of tree node. Simple. Now we have to check if result is not equal to null. If result is not equal to null, then the dynamic memory is not allocated to the result, so we can't assign variable to it. We can't assign our data to result. So in result we have to set result data is equal to our data, and result left pointer pointing to null, and result right pointer initially pointing to null. Simple. This is our create node function, and it gonna return our result node. Simple. Okay, after that, creating a node, let's create some nodes. Tree node, let's name as n1, which is having a value n1, passing to a function create node which is having a data 10. And again let's create some more node. This is n2, n3, n4, n5, n6, 11, 12, 13, 14, 15. Yeah, now our tree nodes are created, but these tree nodes are not connected to each other. So how can we connect it? So we have to connect it like this. Suppose we have a node n1 and we have to put it, suppose we have node n2 and we have to put it, let me open my whiteboard. Yeah, Suppose currently these nodes are created as if we talk about n1, so this node is created as having a node which is having a data 10 and pointing to null node. This is also pointing to null, having right node as null. This is left, this is right, this is n1. Okay, what about others node? It is also same, n2, n2 having a data 11. Left is pointing to null, right is also pointing to nu double l null. Right is all same case with n3, 11. Left is pointing to null, right is pointing to null. So how we gonna make tree from these nodes? So basically we have to put n1, we have to put n2 and connect it with the left node of child, or we can say right, anyone will work. So how can we connect it? So n1 left is equal to n2. Simple. Suppose we have to put right child, n1 right child to be n3. So n1 right child is equal to n3. So this is gonna look like this. After implementing this, n1 having data 10, left child which is having data 11, which is basically m2. It is having right child having data n3, 11. It's 12. It's 12. And n2 having left and right as null, null. Same with n3, because we are not assigned yet the n3 left or n3 right. Simple, right? So now we're gonna see it. So basically our n1 left become n2 and n1 right become n3. And similarly, suppose we put n3 right is equal to n4, n5 and n3 left will be n4. Simple. Is there any note? Yeah, n6 is missing. So we put n5, n5, suppose we put it left, n6. So let's see how our tree looks like. So for that we have to print our tree. So how we gonna print? There are three methods to print a tree: in order, post order and pre-order. These are the three methods in which we are gonna print the tree. So let's talk about pre-order. So in pre-order, it is a void print tree taking our root node as tree node n1. Simple. This is our pre-order implementation. So how to implement pre-order? First of all, we have to check whether our uh, root is null or not. Root is equal to null or not. If it is null, we can print statement that our tree now here is emp empty, and empty we have gonna now return this. In pre-order, we have to traverse it like root. First of all, root will come, after that left child, and after that right child. So how we gonna print pre-order? So just printf, this is the root data, so we can say it as value ampersand d, and our root node data, we gonna say root, so root data. After that we have to print again printf tree. Let's printf. Now we gonna move left side of the tree. Now print tree root left. After that we have to print, as we see here, we have to print right. So printf right. Now we have to pass it to our function print tree root right. Well, simple. And at the end we have to print, if our tree is completed, we have to print and slash n. Now calling the print function, passing our root node which is n1. So let's see. So first of all we have to compile gcc having practice.c. It is compiled, but it's not printing anything. Why? Let me recompile it. Gcc practice a.exe. Yep, it works. So let's see how, because it is printed in such a way that we can't read it. So let's, after value we have to, let me do something. We're gonna put here and save it. Let recompile it. So gcc practice a.exe. So now it's look better. So let's draw this tree, how this tree is gonna look like. So let's start drawing this tree. First of all, we having a root node value as 10. So we having a root node value as 10. After that, the left value of that root node is 11. The left value of this root node is 11. After 11, the our root node is this 11. The left value and the right value both are null. Both are null. Suppose we are indicating null with -1. Here you can write nu double at none is equal to -1. Then again we come back to our node. 11, right, left empty, right empty. 11's having its left child empty and right child is also empty. And here it's gonna end. End. Left child of the 11 is gonna end. After that, we move to our initial current node, which is 10, and we gonna see our right is 14, left right is 12, right is 12, and right is having a left child which having a value 13. Now our root is 13. Now 13 is having a left and right value, both are null, so we are putting -1, and this gonna end. This left child of 12 is end here. Now we come back to our root node, which is 12. Now right 12, right value will be 14, and now our root is 14. Now our root is 14. Now our root is 14, 1 4. So now 14 having a left child which is 15, and 15, and the value of the 15, 14, 14 is having its left child. Let me recorrect it. Left child as 15. Now 15, now our root is 15. 15 having a left child and right child is empty, so we are putting -1. Now our root moves to 14, so there is no right child, so it is also empty, so it is -1. So this is our tree look like. This is our basic tree, how we made here. So that's all. Thank you.